A narrow mountain pass is beginning to crumble. 40 armored vehicles wait on the southern road, engines idling, their crews watching the cliffs above them. Between the convoy and the isolated plateau ahead lies a corridor of fractured shale that has started to slide under its own weight. Combat engineers have less than an hour to stabilize the slope before the mountain closes the only route forward. The highlands rise in steep layers of gray stone and scattered pine, shaped by centuries of wind and sudden rain. The road carved into the ridge was never meant for heavy traffic. Built decades earlier for lighter vehicles, it now carries the responsibility of supporting a modern armored convoy moving toward a tense defensive front on the plateau beyond. The plateau itself is strategically modest, but operationally significant. A small multinational security force has maintained a defensive line there for weeks, monitoring movement across a wide valley corridor. Their position controls communications towers and a narrow airstrip used for reconnaissance flights. If the plateau falls, the surrounding region becomes far more difficult to stabilize. Engineers arrive at the base of the pass before dawn. Their vehicles carry specialized stabilization equipment, portable drilling rigs, robotic support platforms, and containers filled with quick-set reinforcement compounds. The team's commander studies a digital terrain map illuminated inside a mobile command vehicle, while drones launch quietly above the ridgeline to begin geological scans. The drone feed reveals what the naked eye cannot fully capture. Heat signatures highlight fractures deep within the shale layers. Sections of the ridge appear slightly warmer, where friction indicates slow movement. It is a subtle but unmistakable signal that the mountain is shifting. Without intervention, gravity alone may soon collapse large sections onto the road below. The armored convoy is already approaching from the south. 40 vehicles move carefully along the mountain road, spaced at safe intervals. Tanks, armored carriers, recovery vehicles, and supply transports form a long mechanical column. Each vehicle carries equipment or personnel urgently needed on the plateau. Turning back will require days of rerouting through terrain that may already be contested. Engineers move into the pass on foot. The first task is assessment. Geological sensors are placed along the slope, while compact robotic stabilizers roll forward on track platforms. These machines carry hydraulic arms capable of supporting unstable rock faces, while anchors are installed. The process demands patience. Each slab of shale must be evaluated before any pressure is applied. Above the road, layers of fractured stone lean outward at subtle angles. Some slabs weigh several tons, balanced precariously along natural fault lines. Engineers drill into the rock with portable rigs, inserting steel anchors designed to lock the shifting plates back into the mountain face. Each anchor is secured with rapid-curing resin that bonds with the surrounding stone. Across the valley, distant observers appear to have noticed the activity. A mortar round lands high on the ridge, well above the engineering teams. The explosion is distant but sharp, echoing across the cliffs. Small fragments of shale tumble down the slope. The engineers pause briefly, watching the rockfall settle, then continue working without raising their voices. The mortar fire does not appear designed to strike directly at the engineers. Instead, it targets the upper ridgeline, where each impact can loosen unstable rock formations. The tactic forces the stabilization crews to work under uncertain conditions. Every shock wave travels through the mountain's fractured layers, testing the strength of each anchor as it is installed. Robotic stabilizers extend hydraulic supports beneath the largest shifting slabs. The machines hold the stone in place, while engineers drill deeper anchor points. Steel cables are threaded through reinforced plates, pulling the rock faces tight against the mountain wall. Each cable must carry immense tension, while allowing slight flexibility when the terrain shifts. While stabilization continues along the upper slope, another team examines the roadbed itself. Years of erosion and recent artillery vibrations have fractured the narrow lane. Engineers spread fast-setting structural resin into the cracks, creating a reinforced layer designed to distribute the heavy weight of armored vehicles across a broader surface. The work proceeds steadily until the team encounters the pass's most immediate obstacle. A massive boulder blocks the corridor entirely. The rock likely broke free during earlier bombardment and settled squarely across the road. Even the convoy's largest vehicles cannot push it aside. Clearing it quickly without destabilizing the surrounding slope becomes the next challenge. Demolition specialists study the boulder carefully. Instead of placing a single large charge, they mark natural fracture lines within the stone. Small directional explosives are positioned along those lines to split the rock into controlled sections. The goal is to fragment the obstruction without triggering a wider collapse from the ridge above. While the charges are prepared, additional mortar rounds land across the upper slopes. Each impact sends loose gravel sliding toward the road. The stabilization cables tremble slightly but hold firm. Engineers monitor seismic sensors clipped to their equipment. So far, the readings remain within acceptable limits, though the margin of safety is narrowing. The demolition sequence triggers a sharp echo through the pass. The boulder splits along its fault lines, breaking into several large pieces. Some fragments tumble over the cliff edge into the valley below, while others remain scattered across the road. Heavy engineering vehicles move forward to push the remaining debris aside. Dust drifts through the corridor as the clearing operation continues. Above, drone cameras circle slowly, providing continuous updates on slope stability. Several cracks along the ridge widen slightly after the demolition blast, but the reinforced anchors absorb most of the stress. The road is open again, though still vulnerable. Attention now shifts to installing protective tension, netting along the most unstable sections of the cliff face. These heavy steel mesh systems are designed to catch falling rocks before they reach the road. Climbing teams move carefully along the ridge, securing anchor bolts into solid bedrock, while winches below pull the nets into position. The installation process requires careful coordination between teams working above and below the road. Each anchor point must align with calculated load paths capable of absorbing falling debris. The mesh is tightened gradually, forming a protective barrier that stretches across nearly 200 meters of exposed slope. By mid-morning, the distant rumble of engines becomes audible through the mountain corridor. The armored convoy has reached the southern entrance of the pass. The first vehicles halt, while engineers complete their final inspections. Every anchor, cable, and reinforcement joint is checked once more before the signal is given to proceed. The lead tank enters the corridor slowly, its steel tracks pressing against the newly reinforced roadbed. The vehicle's weight vibrates through the ground, sending faint tremors through the shale layers above. Engineers watch the sensor readings closely, ready to halt the convoy if the numbers climb beyond safe thresholds. One by one, the vehicles follow. Armored carriers and support trucks move through the narrow corridor in measured intervals. Dust rises behind the column as sunlight filters through the suspended haze. Above them, small stones occasionally strike the tension netting, rattling against the steel mesh before settling harmlessly into the woven structure. Another mortar round lands along the upper ridge. The explosion triggers a brief rockfall that cascades toward the road. The newly installed netting intercepts most of the debris. Several fragments bounce against the mesh and fall away into the canyon. The convoy continues moving, its pace steady and controlled. As the heaviest vehicles approach the center of the pass, seismic monitors record a noticeable increase in ground vibration. The mountain responds to the weight passing beneath it. Engineers exchange quiet updates over the radio network, comparing real-time readings against their projected tolerance levels. Across the valley, defensive units supporting the operation respond to the mortar fire with controlled suppression strikes aimed at suspected observation positions. The opposing spotters gradually lose clear line of sight. The incoming mortar rounds grow less frequent and less accurate as the convoy advances deeper through the corridor. At the northern exit of the pass, engineering vehicles clear loose gravel and fractured rock that have collected along the final turn. Bulldozers push debris aside while technicians guide the lead armored units onto the wider plateau road. The first vehicles emerge from the corridor and accelerate slightly once the terrain opens. Behind them, the remainder of the convoy continues through the stabilized passage. The road vibrates steadily beneath the combined weight of engines, steel tracks, and armored wheels. Sensors embedded in the slope report increasing strain along several fracture points, suggesting the mountain will not remain stable much longer. The final vehicles approach the exit ramp as small rockslides begin to break loose along the upper ridge. The tension nets catch much of the falling debris, but the corridor stability is clearly fading. Engineers withdraw their remaining equipment and move their vehicles out of the pass as quickly as conditions allow. Minutes after the last armored carrier clears the corridor, a large section of shale finally collapses along the upper slope. Debris spills across the roadway that moments earlier carried a relief convoy. The reinforced netting absorbs part of the impact, but the pass is no longer safe for further movement. Hours later, the armored column reaches a plateau and links with a defensive force stationed there. Supplies are distributed, vehicles repositioned, and the defensive line strengthened. Far behind them, the mountain pass slowly settles back into silence. For a brief window that morning, engineering precision turned a collapsing ridge into a working road, long enough for the convoy to pass.